So thank you very much indeed for coming along tonight. In fact, thanks to Quinn for making this happen, essentially. You're at Not So OT. If you're not supposed to be here, then well, what are you doing here in the first place? This is a... Oh, I can hear myself look in the background, which is nice when you stream to YouTube. We do have a code of conduct in place. Really, it just boils down to be nice to everybody. This is stolen from the Microsoft code of conduct. Being as an MVP, I'm allowed to do that. But if you feel like anybody is going against our code of conduct, then just DM me in the Zoom DMs, and then I'll sort out whatever problems that you might be having there. So just be nice to people and we won't have that problem. We'd like to thank our sponsors. I feel like I'm... oh, yeah, that's right. So we did have Tech Nottingham in that top right-hand corner, but sadly no longer. So my company are sponsoring the time, but actually I'm now with Avanade. I still have my company, but that's just running in the background. But Calix, they're sponsoring us a piece of IoT tech, which is to be decided between Quinn and I at a later date. And also the Zoom license that we're all using at the moment. So thanks very much to them. And JetBrains, they're sponsoring us a product which we're going to be giving away. If you tweet on the hashtag NotsIoT, then you will win one of you three. I've got a good chance of winning a JetBrains license, a code for any one of their single products. If you don't know what JetBrains are, they make developer tools for developers. So things like PHP Storm, WebStorm, IntelliJ, and ReSharper, and some of those popular tools like that. All awesome stuff. So tweet on the hashtag NotsIoT, and at a later time, I'll draw that and get in touch. Likewise, Calix are also sponsoring us a piece of IoT tech. Quinn and I will decide what that is. But again, I'll pick that out of the tweets on the hashtag NotsIoT later on and get in touch with the winner. We do have a backlog, actually, of two previous events that I've not done that for yet. So somebody who came along like 3 months ago is going to have a nice surprise at one point when I tell them they won some tech. So yeah, thanks to Calix for sponsoring that. I mentioned that I'm an MVP. And in fact, Quinn, you work for Microsoft. So there's a Microsoft theme here. But if you're interested in finding out what Microsoft MVPs are up to, then do get in touch, and I'm more than happy to speak to you about that program. It's awesome. So tonight we've got Quinn Damerel speaking about Octoprint everywhere, essentially. So it's going to be a really interesting topic of conversation. So looking forward to hearing about that. Coming up on the 28th of November, we've got .NET Knots back in person, and it's hybrid, so it'll be online as well. But if you're around the Nottingham area, then pop along to BGSS to see Stephen Pears talk about open source with .NET and Roslyn, which will be quite cool. And in fact, Quinn will be coming along and doing a far more .NET and Microsoft-centric version of this talk sometime in the new year. So keep your eyes peeled for that. That'll be a good talk, that will. If you're interested in IoT, then I'd highly recommend you taking the AZ220 exam. And if you want to take that exam, I helped write it, and I've also helped to write some Pluralsight content to help you pass it. So do go check that out. It's worthwhile if you want to take your IoT interests or career to another level. Also, coming back probably in the new year now. In fact, I'm missing a slide here. I should have another slide on this, talking about the reason why we're not doing IoT Live is because we're preparing for flight into IoT 2. And I'll put a link for that in the chat, but that's aka.ms/tech days. And that's a week today. We're broadcasting live from Thames Valley Park in Reading at the Microsoft HQ there. And there'll be a bunch of us talking about all sorts of IoT stuff, from digital twins and 3D models, Power BI, Stream Analytics, Azure Data Explorer, IoT Hub devices. 3 hours of IoT geekery next Thursday from 2 p.m. So free to register. It'll be on YouTube as well, I'm sure. So do go and check that out. And tangentially, completely, because it's nothing to do with this, I'm also part of the Agile Engineering podcast with a few other folks. Do go check out the Agile. We're on all good platforms. Go and check that out. So that's enough of me blathering on about slides. I will switch you over to Quinn for the interesting part of the evening. So thank you very much.
Cool. Thanks. Let me share my screen. I'm just going to share the whole thing. Hopefully it's pretty viewable. I downgraded the 1080p, so it would be better resolution for streaming. Yeah. So, hi, I'm Quinn. I do work at Microsoft. So my day jobs, I work at Microsoft, and my night jobs, I have a family and I work on Octo Everywhere. And so, since this is IoT, I tried to orient the talk towards kind of the more, I guess, like the client side, I guess you'd call it, kind of systems, the IoT systems. Um, Let me see if I can open chat. I'll put it over here. Okay. To start off, if anyone wants to, either feel free to type in chat and I'll try to keep an eye on it on my other monitor. By the way, if I look over here, it's because I have another monitor. And or just unmute and feel free to jump in and ask a question. Like I said, I oriented this towards IoT based stuff, but I'm happy to talk about anything about the service. There's a lot of interesting things, I think, at least. Yeah, so I'll just get right into it. So a quick overview. So Octoprint, 3D printing, Octo Everywhere, and then some interesting, what I thought was kind of interesting tech I built in Octo Everywhere to secure IoT devices. Obviously, security is a huge thing. IoT is a huge thing. Security is a huge thing in IoT because you have all these little things like your light bulbs, and they have little computers in them. And if they happen to have some exploit, you can hack them. And basically, if you can get from the public internet onto any of these little devices, even if it's a light bulb, I mean, you have, enough power to then get somewhere else in the network because you're in this local network that's really not set up to defend against, like public internet kind of noise or bad people. So I picked these fun slides because they're nice and pretty. I couldn't get the text on here to to be correct, so don't mind that. Yeah, so I'm Quinn Damrell. I'm a software engineer at Microsoft. I've worked at Microsoft 10 years now. I worked on Windows Phone, then I worked on a project that canceled. I did some stuff on the WSL system in Windows. I worked on Xbox, then I worked on Mixer.com, then I worked on, and now I'm working the mesh slash what do you call it, the holoprotation part of Microsoft. So that's not really relevant, but that's what I do. So starting the talk, why Octoprint? So 3D printers, there's kind of two types of 3D printers. There's these traditional ones, like here, this is an Ender 3 Pro, I think V103 Pro, are these dumb offline standalone appliances. They basically, I think you see my cursor, yeah. In this little box here, there's a little microcontroller, and it just has no connectivity. It's gonna do what it's gonna do. There's a little slot right above the cursor there. That's where you stick an SD card. So the only way you interface with this thing is you have the screen, you have this little knob that you can click to select, and then you have an SD card. And so basically the way you use a printer like this is you get a model from anywhere, you use some piece of software on your PC called a slicer to convert that 3D model into what's G code, which is basically like assembly for a 3D printer. It's literally just like a list of commands, like move the X axis, 3 millimeters and then extrude, and move the Y axis X millimeters and extrude. And so that G code, you put it on the SD card, you stick it in the little slot there, you scroll around on the printer, you hit print, and it goes and prints the thing following the G code. It's a very basic computer in there. It can't do a whole bunch. It's commonly ran this software called Merlin. It's a firmware, and it, for example, I think has to be less than like 30 kilobytes to fit on the flash ROM in it. So it's like very, it's basically a little IoT thing, but it's offline. So that process isn't ideal. 3D printers are notorious for being a little fussy. So they may your print may dislodge from the bed, and it might just start extruding all over the place, which they call spaghetti. There's a lot of failures that can happen. And some 3D prints take an hour or 30 minutes. Some 3D prints can take multiple days, depending on how big it is. And so if you have something printing all day long, you kind of want to keep an eye on it. If it fails, you don't want it to just keep going, because then it's going to waste your filament, which is the plastic it uses to build the thing. The control system can be a little hard. You see a little screen down there. It's just basically an LCD. You got to kind of futz through it. It has some menus and stuff, but it's a little difficult to navigate, and obviously somewhat limited in its capability. And there's not a lot of real-time information. Basically, you get like the temperature. I guess we get the temperature of the nozzle in the bed and a few other little things from a standard printer. So that's basically why 3D printers are great, but they're also dumb. There is a new class of 3D printers, I'll speak of real quick, which is like 1,000, like more expensive ones, like higher end consumer and like low grade enterprise, that are basically like they have the 3D printer and the equivalent of Octoprint and a whole like cloud ecosystem built into them in their own little closed ecosystem. Like the Bamboo X1 Carbon is a really popular one that got kickstarted a little bit ago. And those are like their own little ecosystem where they have the printer and it has the software on it, it has a phone app you can use to control it. And it's a whole little thing. So there's kind of those things are their own little ecosystems of fully connected cloud things. And then there's these like very basic, not connected things. So if you have one of these very basic not connected things, you can use Octoprint. This is a screenshot of my Octoprint running. Octoprint is magic. Octoprint is, if you're a tech guy and you have a 3D printer, it's like everything you ever wanted it to be. It is basically a local, it's a local web server that runs on some device somewhere that you plug into your printer. And it lets you control the printer on your local network. So it lets you send files. So when you have your G code, you can just, take it from your desktop and drag it into the browser window and it'll automatically upload to it. You can see the webcam if you set it up. It supports the PyCam and like a whole bunch of other, like basically any kind of USB webcam that works on Linux will work with it. It lets you have a whole bunch of real-time statistics about your printer and what it's doing. It shows you percentage, time, and it's super pluggable. So the Octoprint I should start with is written by a woman named Gina. She lives in Germany. She's also spectacular. She maintains and develops the entire thing. And she has made this just incredibly extensible system in Octoprint. I mean, almost anything. The whole UI website can be extended. Most of all the backend, even like the API calls, authentication, all that stuff is extensible. So you can install plugins. There's like a plugin manager system here in Octoprint. You can install plugins that can basically empower it to do anything it wants it to be. There's a lot of really amazing plugins. Like there's one that Octoprint will predict how long it's going to take based on like some really rudimentary metric about like how long it's taking to process a G code. There's someone who wrote a plugin called like Print Genius that actually does like a full parse of the G code and like a virtual print of it, like using like delays that would actually take to execute the commands to build like a much more accurate print time. And so that's a plugin, like literally go into Octoprint, click install, restart Octoprint, and it's just there. And then all of a sudden this thing just starts working. So things like that, there's a million of them. They're super cool, super extensible. Yeah, make sure I covered everything. Oh yeah, and so obviously with Octoprint, you can keep an eye on your print, from your couch while you're playing games or whatever. So if it fails, like in this picture, actually, there is a failed print down there. You can see it's kind of messed up under the extruder. You can go stop it and it doesn't waste a whole bunch of filament. And so Octoprint runs almost anywhere. Octoprint is based in Python. And it's pretty much self-contained. The only thing that's not part of Octoprint is the webcam system. The most common way to run Octoprint is on a Raspberry Pi. Anything more powerful than a Raspberry Pi 3 will run it. So a 3, 4, and a Pi W, Pi W2 is even powerful enough to run Octoprint, which is really incredible. Back in the day when those were like $30 and Pi W2s were like $15, it was a great solution. But since Raspberry Pis now cost a lot more, hopefully not for too much longer, there's a lot of other ways to run it. There's a million different like alternatives to Raspberry Pis that are basically the same thing, but like the Rock Pi and like a lot of other ones like that. There's other like completely different systems, but that can run the software. There's a project called Octo 4A, which is really cool. That's if you have an old Android phone, someone made an APK like Android app you can install that basically will run all of Octoprint. Like I don't even know honestly how it works, but somehow it downloads all the Python and runs it as a background service on your Android phone. And so you can use your Android phone, use the camera built into the Android phone, just basically point it at the printer, plug it in the printer, and you have full Octoprint running. And I mean, who doesn't have an old Android phone laying around? People also run it on old laptops. You can run it on Windows. You can run it in Docker on Windows, so like running it in WSL and Linux or whatever you want. You can run multiple instances of Octoprint on the same hardware, so you can control like multiple printers with one computer. Super cool, super extensible. There's a ton of community support around it. The community is great. So that's Octoprint. Octoprint is not my thing. Octoprint is Gina's thing and the community that writes it. What my thing is called Octo Everywhere, which is a little confusing, but all the Octoprint plugins, most of them start with the prefix Octo because it's kind of the thing. Oh yeah, sorry, it's just caught it in the chat. Yeah, the Print Type Genius plugin. Yeah, exactly. Whoever posted that. That one's great. And there's a link there. There's the plugins at octoprint.org. There's like a list of all the plugins and like the top ones and the rising ones and all that stuff. So, and you can search them. So anyways, oh, here, let me show you. So I was going to just show you guys some. So here's octoprint.org. Super easy to set up, download. Sorry, I didn't mention this. The most common way is a Raspberry Pi. There's an image called Octopi, and you can even use the normal. There's that like the Raspberry Pi imager tool that just like is built for Raspberry Pis. It has this built into it. So if you just use that imaging tool, you can just click like, select Octoprint and you're there. And it will just, flash SD card, everything it needs. You stick it in, you're off to the races. Real quick, the plugin page is here. These are like the newest ones. You can see the top ones here, the trending ones. And then you can search anything like if you want Telegram notifications, there's plugins that do that. Mine actually does that as well, but there's like, you could basically search anything you can think of. And there's some plugin that'll do it basically. And then real quick, this is Octoprint. Mine's running. I'm running a print right now. This is out in my garage. So this is what Octoprint looks like by default. For example, one of the plugins I installed kind of does this with it, which makes it a format where normal Octoprint. Oh no, I was afraid I was going to do that. Don't worry. I have the technology to fix this.
Oops.
Yeah. Octoprint by default doesn't like scale. And if you put it in kind of like a mobile mode, it doesn't really do well. So this plugin kind of redoes all the UI. So anyways, ton of plugins. This is what Octoprint looks like. It's right. You can use it to control things. Right now it's printing. You can see temperature graphs. You can see the terminal of what it's talking to the printer. This gives you this is really cool. It gives you a full little view of what's printing in real time. So if I had the webcam open, you'd see like this is where the print nozzle is and it's moving through and you can go up and down. I'm printing a thing called Benchy, which is the default thing you print. So anyways, that's what Octoprint looks like in real time. So what Octo Everywhere does is, I'll tell you the quick backstory. My wife got me a 3D printer almost completely sporadically. I mean, I love tinkering with stuff. I loved IoT things, but I didn't have a 3D printer. I got it. I was like, wow, this is really cool because I never really thought about this. I put it together. It's the Ender 3. It's sitting behind me if you can see it back there on the floor. And it was great. I really enjoyed it. I installed Octoprint on it. It was incredible. I loved all the plugins, loved all the stuff. But at the time, there were remote plugins for Octoprint, but they were basically like, you'd go to a website and you'd see like a screenshot and then there'd be like a button that's like pause or cancel, and like you'd click that and it would like kind of proxy it to the printer and execute the command. But the cool thing about Octoprint was the webcam stream, the plugins, configuring exactly as you want. My instance there has like just 10 plugins running in it, do all kinds of stuff I like. And you couldn't get that. And so what a lot of people did, kind of jumping ahead, but what a lot of people did was they would port forward, and port forwarding is absolutely terrible, but we'll come to that later. So I was like, I think there's a better way to do this. I had this idea. I do software and I was like, I feel like I'd never really done a service like this before. But I was like, I feel like there's a way to do this. So I made this prototype that was absolutely terrible. And I put it on the Octoprint forum and it got pounded by the users because I thought it was so cool. And it literally took it down. It was an Azure app service actually at the time. And it would restart every 5 minutes and it just couldn't keep itself up. It would just keep restarting and dying. But people liked it when they could get it to use it for a minute. They're like, oh, this is cool. So I knew it had legs. And so I just went off and built it then. And I took about 3 months to kind of rebuild the service. And then it's evolved a lot since. And that was about 2 years ago. And now we have Octo Everywhere. So the main purpose of Octo Everywhere is to give you access to your full Octoprint portal from anywhere. So from any web browser, basically over the public internet. And so it kind of takes this, you have this simple 3D printer. Now you have this IoT, Raspberry Pi or whatever you have, even more powerful thing plugged into it. So you have a dumb 3D printer. Now you have a LAN 3D printer, like a local network, 3D printer. And then now we have this IoT device that's accessible from the internet. Obviously, it's super cool. Obviously, security is a big thing on that. So that's why I have some slides on it in the future. But so since then, I've added some features. AI failure detection is something I just added recently. I'm going to talk about that one a lot more in the EML.net presentation. I think it's going to be like the end of January. So if you're interested in this stuff, like AI and how that works, definitely check that one out. But other things like printer notifications, I've been getting a few. Show you quick. So like this is a printer notification. This is, I was just playing with it earlier, but I don't have a, like, basically you can choose whatever you want, but you get these screenshots, you get all these estimates, stuff like that. You can get progress, like this was the first layer is complete. You can get every hour, every 10% on failures, on pause. If the AI detection system detects a failure, it'll send you a notification. So that's pretty cool. Live streaming is a cool one. If you scan this QR code, I set up, so this is Octo Everywhere's website. Let me refresh this. This is a feature I added called live links. It's not working super well, but this is a full webcam stream. And so any user can create this live link, which is just this little slug on the tail of this thing. And then they can share it. And it gives you this real-time view of anyone you want. And it works really well on mobile. Like if, you can open up on mobile. You normally don't see this. This is if you're the creator of it. But anyways, it's super cool because it lets people share their prints with their community. People tweet them, and then anyone on Twitter can come look at it. And it's completely secure way of doing it. This doesn't give the user viewing obviously any access to your printer beyond these kind of read-only feeds. And the person can revoke it, delete it whenever they want, and they're time-based or whatever. So live streaming is pretty cool. Sharing is you can share the whole portal with someone. You can give them access to the whole portal if you want to over the internet. I've had a lot of people tell me that their son or their dad lives a state away, and they'll share the portal with them so they can kind of both interact with the printer and look at Octoprint stuff. App support. So since Octoprint is kind of an open source thing, there's a whole bunch of app developers who create apps, really good apps for Octoprint for iOS, Android, and all kinds of devices. I worked with them to integrate Octo Everywhere into their apps so that you would just log in via this kind of OAuth style portal, and then your app works anywhere. You leave the house. Obviously, if you have an app, the whole point of it is kind of to not be at your house, to use your phone probably more, right? If you're at home on your phone, you'll probably just use your laptop or something. So having that work anywhere is super cool. And it's a completely secure way of doing it. There's other features too, but that's basically the high level ones. So that's what Octo Everywhere is. I guess real quick, I'll show you just this. So this is kind of what the dashboard looks like. And, so this is my dashboard. My printers, this one's just a test printer. That's why it's looking at nothing. More test ones. But yeah, it's this is Gadget, the AI feature. This is Quick View. This looks very similar to the streaming UI, but this is per my account. So I have a little more information. You can see Gadget, this is my AI system, and it's saying that this print is looking great because there's no problem with it. If it had some failure, this would start complaining about it, send you a notification, ultimately pause the print. But yeah, so I can hit connect here, and then boom, actually what I showed you earlier was my Octoprint portal through Octo Everywhere. This isn't even local. This is my Octoprint. I think if I do, I think 57 is the IP address of this one. Yeah. So this is Octoprint on my local network, and this is Octoprint over Octo Everywhere. As you can see, it loads just about the same. So anyways, it's the full thing, full webcam stream, plugins, all that jazz. So when I first did this, a lot of people were like, oh, sorry, hold on. Let me pull my chat. I think it closed when there you go. Okay, so when I first did this, everyone was like, oh, but security, right? The problem with the thing about Octoprint is that one is plugged into a 3D printer, and 3D printers get really hot. They have to extrude the plastic, the filament through them. So they get 200 degrees Celsius, for example, on the hot end. Some of the older 3D printers didn't have a lot of good thermal management for that. And you could basically tell it to heat up to infinity, and it would heat up until it melted. Most modern 3D printers won't let you do that, basically won't let them burn themselves down, but you could on the old ones. And the concern is that if this is on the internet and someone gets access to it, they can just heat this thing up and burn my house down. So security is a really big issue. And also Octoprint runs on a Raspberry Pi, and it has the ability to actually run shell commands as some of the extensibility of it. So if you were able to get on Octoprint and get access to the user account, basically you could run a shell command on the Raspberry Pi and then just, take over the Raspberry Pi. And then you're in someone's local LAN with, full access basically. So not good. Anyway, so a lot of people want to access it from home though. So back in the day, a lot of people did port forwarding. I actually did this. I'm guilty. Oops, my headset turned off. Just check, make sure that worked. Okay, perfect. So I port forwarded. I was part of the problem. And it's really bad because Octoprint, first of all, has no SSL. So whenever you do your like user authentication to it's just pure text or plain text. And Octoprint's user system is not secure enough to be on the public internet. It has like a user authentication system with like you could set different account levels and have like view only accounts and admin accounts and stuff, but it's not like tested enough to be internet secure. There's probably an exploit you can use to get around it. So it's, you should absolutely never put Octoprint on the public internet through just like port forwarding or whatever you want. So like I was saying, at the time, there were a few that did it through that. And I created Octoprint so it would do everything. And then as Octo Everywhere got bigger, I really just like the 3D printing community and the maker community and the Octoprint community is so like, there's a Discord where most of the Octoprint community is, and there's so many people on there. They're so helpful. They're so nice. Gina's on there. There's like, I think 3 or 4 other people who like do a lot of other work in Octoprint. They're on there. They'll help you with any questions you have. They're just like, they give the community so much and for free. I mean, a lot of the models you download are free. So I wanted Octo Everywhere to kind of be the way I could like give back to that free community. And so my goal with Octo Everywhere was to make it like a secure, solid, extremely easy to use. Like you don't have to worry about managing it, hosting it, or anything. You don't have to worry about, you know, if you're VPN, keeping your creds up to date and updating the VPN software in your Pi and whatever, having it public exposed. So super easy to use, super secure, and then like as free as possible, as I say. Obviously, it costs me money to run it, but I have a supporter system people can use to optionally like, you know, pay a monthly thing to support the project. So, but anyway, so support was the top, security was the top priority because of what I was saying about security. This is kind of some of the details on it. I thought some people, if you're kind of more tech-minded, would be interested. And like I said, feel free to chime in if you have any questions or put them in chat. But so the Octo Everywhere plugin is Python based. It's on GitHub. You can see it. Pretty much all Octoprint plugins are on GitHub. So it's Python based. You install into Octoprint via the web UI. You just click a button and it installs. To make the connection secure, I had to figure out how to basically get the printer connected to the server securely, and then get the user connected to the server securely. And then when both of those trusted links are connected, then you know you can access things. So on the plugin side, it uses a WebSocket, which uses TLS 1.2 because that's what I've configured. But basically, you know, a standard HTTPS WebSocket using modern protocols. And it connects obviously with an SSL cert. I use Let's Encrypt on the servers. They generate their own certs. And the thing is that only I should be able to generate a cert for Octo Everywhere. And so the WebSocket connecting to the web server, if it successfully does the SSL connection, should then assert that it's connected to an authentic Octo Everywhere server. And then, you know, it knows it can be trusted, because the plugin has a problem where it's like, it's saying, I'm going to reach out to some server and I hope it's the thing I'm expecting it to be that I can trust. If it's not, then someone could like man in the middle that attack, could attack that and man in the middle, and, you know, basically run a different server that's going to, the printer connects and then the server sends it commands to like overheat itself or whatever. So I wanted to make sure the plugin could really trust it. So the SSL cert should kind of guarantee that. But since SSL certs are, there have been exploits where people are able like to mint certs for like the domains they shouldn't be able to. And since I use Let's Encrypt and stuff like that, it's not, you know, quite like a DigiCert level, not trustworthiness, but just like the system. I don't exactly know the right terminology, but it's just not quite all the way there. So I also added this kind of cool RSA public private key challenge. And so as long as the plugin code isn't tampered with, as long as you can't change the Python, the plugin code, the plugin creates a random string. I think it's like 32 or 64 characters. Actually, it might be bigger than that. I can't remember. And it encrypts it with a public key, RSA public key. And it sends that as part of the handshake. And then when the server gets it, the server then has the private key, and it can decode the original plain text and then send it back to the printer. And so basically in doing such, the printer, the local plugin can create a secret that only it knows, encrypt it in such a way that it can't be tampered with, give it to the server, and then the server can decrypt it and send back the exact same plain text and prove that it is able to use the private key to decode that. And so in that way, it kind of adds this another layer of security on top of the SSL stuff, because only the service has the private key in the logic of the service to decrypt that system. And so, like I said, if someone is able to man in the middle of the connection and they're able to generate a cert that was valid for the domain, the plugin would not connect to their server because they don't have the private key required to satisfy that challenge. And if the challenge isn't satisfied by the printer, it'll just disconnect, and it won't take any commands until the handshake is complete. So that's kind of a cool system. The only downside of that is that if you have the ability to like mess with the plugin code, like you're on the Raspberry Pi, obviously you could just disable that Python logic and get around that. So, but assuming your client's not compromised, then you're good. Certificate pinning. So I listen to Security Now, plug on the Twit network, and I really love that show. And I remember talking about security pinning, certificate pinning, but I honestly can't exactly remember what it is. I know it's a like extra security measure on top of certs. Real quick, the reason I have to use Let's Encrypt is because, as I'll get to in a little bit, the Octo Everywhere servers kind of create a mesh network of servers among each other, and they create a mesh network. And most of the time, you're always connected to the most ideal server in terms of latency for both the printer and the user, but sometimes you're not. And if you're not, I have to redirect you to a server cluster explicitly. And so I use a domain name that's like some domain dot the cluster.octoeverywhere.com. And so I have to support SSL certs for octoeverywhere.com, star.octoeverywhere.com, a wildcard, and then star.servercluster.octoeverywhere.com. And Let's Encrypt, well, so basically every one of those wildcard domains, if you use something like DigiCert, would have to be its own cert, because I don't think they let you like put them together. And certs are like $800 a year, so like that. And so basically I would have to have one cert for every server cluster I have. And right now I have 9 clusters around the world. So that just doesn't scale with the project size I have and the funds I get and stuff. So I use Let's Encrypt because I can basically create those wildcard certs. And I actually wrote a little bot in .NET that is on the server now. I used to do it by hand, but now the bot does it itself, and it's able to generate an SSL cert specifically for that cluster. So I don't have to update them anymore, which is nice. I know there's things like there's the cert, what's it called, certbot, I think, which like kind of does that for you. It can even like automatically put in Nginx the way it should be and everything, but it doesn't quite work for my scenario. So I just wrote a little thing around it. This is reading this comment. So the public-private pair key question. Yeah, so the public-private pair is like, the plugin creates the unauthenticated HTTP connection, SSL is established. So at that point in time, the WebSocket is known to be secure because it's basically running over the encrypted SSL. And because SSL asserts that only octoeverywhere.com can get this SSL cert, it should assert identity as well. And so in that trusted context already, then the RSA little encryption public key, private key thing I do happens. So it's just kind of like another layer inside of that. And then, so once SSL is established and the RSA challenge is established, then the printer's like, okay, good. Or the service is like, okay, you're allowed to do this. And then the server sends back some keys that the plugin can use. Another interesting thing about a challenge here about security is that Octoprint basically gives plugins full reign of the system. They can read the file system. They can do basically anything. And so I was a while thinking about, well, how do I prevent a malicious plugin from grabbing some context about Octo Everywhere from like the system? Because all plugins run in the same like Python process. So they all run the same memory space. So basically, like, with Python, you can go explore other classes you're not supposed to be in Python, right? So some malicious plugin could load in the same process and kind of mess with Octo Everywhere stuff. There's obviously nothing I can really do about that too much, because if there's a malicious plugin running in memory, like it can explore the memory and grab whatever it wants. But I tried to thwart it a few different ways by like, the server gives back the plugin some like auth keys basically that are just like they're very short, kind of time based, and it never writes them to disk or never writes them to Octoprint settings. So Another concern I had was that if you like get an app and you give it access to Octoprint, it can call the settings, and the settings is basically embedded dictionary, like a dictionary hierarchy of things, like a JSON object basically, and it can see the settings for everything. So if I save those auth keys into the settings, then anyone who had access to Octoprint can call the settings API could get that. So I only keep those auth keys basically in memory. And so they're not written to disk. They're not accessible via like apps or anything that have like, permissions to access Octoprint. So if you had a plugin running in the same process, you could muck with the memory and go find it and grab them. But at least, if you're like a authorized client, whatever, you can't get access to those keys, which basically means you can't present yourself to the Octoprint APIs as the printer. Let's see. Are you using... to check the identity of the server? Yes. So the RSA challenge is to it's probably a little bit of overkill, but it's just kind of fun to do anyway. So but basically it lets the plugin, assuming the plugin is like the source from GitHub and it's not mucked with and like it's valid, it allows the plugin to assert that it is connecting to a Octo Everywhere server that is valid. Yeah, no such thing. Yeah, so like what I was kind of saying is my concern was that if someone was able to like man in the middle, or like say in the future Octo Everywhere goes down, the service ends, but people still have the plugin installed, and I let the domain name lapse or something, right? Because I don't want to pay for it anymore. Someone grabs the domain name octoeverywhere.com. Now, anyone who still has that plugin installed, and in Octoprint, there's a good number of people who just have Octoprint running and it's just sitting there and it's like, 2 years old and they never update their plugins. So that plugin would just willfully try to reach out to octoeverywhere.com. And if someone had a server sitting there, it'd be like, yeah, sure. Like I'm Octo Everywhere. What do you want to do? And so if that happened, then, they wouldn't be able to, the plugin wouldn't connect to them as long as they're running a version that has a SARS thing in it, which has been in there for about a year now. And so, yeah, that's kind of the stuff I was thinking about. If someone is able to basically claim their octoeverywhere.com and had to correct SSL and stuff for it, the plugin wouldn't work as long as you have the private key. Only the service has. Yeah, so this is kind of the plugin side, kind of some of the security challenges that I thought about and tried to kind of prevent. Some of them, like the time-based auth keys, obviously, like I was saying, aren't 100. There's no solution that's 100% good. Like I cannot protect against a malicious plugin basically in Octoprint. I can protect against a malicious client who has access to Octoprint by not putting the keys in the APIs, like I was saying, and stuff like that. But there's no way to do it beyond that. So I got it as far as I could. Try to do stuff as best I could. The main would expire untrusted network DNS. Yeah. So exactly. Poison DNS server. A poison DNS server wouldn't work in this case unless you also had an SSL cert that was valid for the domain. But if you were able to, so I guess if you had if you had the root CA cert on the device hacked and you minted yourself a cert that was valid for that root CA for Octo Everywhere, then you could do it. If you've hacked the root CA, then you're probably beyond even caring about that. But poison DNS servers, maybe like local IT, people having local IT servers, maybe they have their own, like an enterprise had their own CA cert for some reason they put on there, and someone got access to that enterprise CA cert. And, who knows? Probably more than an average consumer would ever run into running the system, but never hurts, and it's fun. There's ways to get certs, sorry. Let's Encrypt is the arbiter of their certs too, right? And the same way DigiCert is. If I think there was a exploit on DigiCert or something a little while ago, and it wasn't like a big one, but somehow someone was able to mint like a cert to a domain that didn't get trusted. Because that's basically, DigiCert can mint anything. It's the DigiCert logic that prevents users from doing that. And so if there's a bug in that logic, now you can start minting certs for google.com, whatever, it would be terrible. And so, someone could accidentally introduce a bug in there at some point in time that would do that. And, Let's Encrypt could, because Let's Encrypt is great. And I totally love them. I think like what they do is perfect and everything, but they're not, they're not a huge tech company. So anyways, so then on the client side, on the side of me trying to connect to this thing, Most of it's all web browser based. The apps are apps, obviously, but they run over, they use HTTPS and WebSockets to connect. So it's basically the same thing. I use the latest TLS HTTP. I think a little further on, I run Ubuntu servers. I update them daily. I have Nginx running in front of the .NET Core server, which I actually don't know if is required anymore. Back when I was doing .NET Core originally, like in the 3.1 days, I think it was advised not to put .NET Core directly on the public internet. But I think with newer Kestrel and stuff, you can. But anyways, I still run .NET, or run Nginx in front of it. Yeah, Kestrel wasn't secure, but I think was it .NET 6? I think they moved to like, they merged Kestrel into all of it. Yeah, same. So that's why I run Nginx in front of it, because it's like the standard, right? And I figure, I don't know if this is true, but it's C, so it's handling all that SSL stuff in C, and it just feels like it'd be a little more efficient, but I don't know if that's true. Anyways, I run Nginx in front of it. Nginx does the SSL termination, forwards it on to the .NET Core server running all the logic. So it's fully TLS, all the latest TLS, HTTPS. I've been gunning. I really want to do HTTP3, but Nginx still doesn't support it. So I do have Cloudflare set up, and so for anything that's CDNable, it runs via HTTP3. But I'm really hoping that Nginx updates their quick support soon, because I think it's cool. User accounts can be protected by third-party auth systems, which is something I added about a year ago. And actually, I kind of hated third-party auth systems, all those stupid like sign in with Google buttons and stuff. But now I actually kind of really understand why they exist. That Google doesn't get a lot of information about you. Obviously, since the button's loading, they know you with your cookies on this website. But the advantage is, instead of me building my own auth system and having to secure it and trust it, I'm basically just relying on Google, because they give me back a token that I can validate against them. And I'm like, okay, as long as the user is able to get this token, they're good. And so, Google, I'm sure, has gazillions of engineers working on, spoofing and spamming and multi-factor and all that stuff to be like, if you're able to generate this token, then you're really logged in as you. And so it kind of puts the identity assertion problem on Google or on Apple. I support Facebook. I might not support Facebook in the future. Not many people use it, and I kind of don't like Facebook. So Apple's is pretty cool too, like the one touch thing, especially if you're on an Android or an Apple device. The Apple thing, you hit it, pops up a little prompt, Face ID, you're done. Google's the same way, I think, on Android. So that's pretty cool, just for users to have a quick, nice way to get in. Optionally, on top of that, you can do an MFA, two-factor code based, not like SMS, but rolling code in the app type thing, authenticator app based thing. And then if you don't have MFA set up, the system's set up to do basically a email access code check. So if you try to log in, you don't have MFA set up, and you're on a new IP address you never logged into before, it'll send you an email with a code you have to type in to verify it's you. So I really wanted to protect users. Of course, again, a plug for security now. We all learned that users are notoriously bad at security. They use the same password everywhere. If you know someone's email address and their plain text password, you can basically get in, because you can just spam that across all the services you can find that have accounts in, and they share the password, so it's all there. So the email-based two-factor was kind of against that. I really wanted to make sure that a user couldn't shoot themselves in the foot by using a bad password, a reused password, whatever. WebAuthn is really cool. I want to implement it. I'm a little concerned about how it works in terms of the keys are local to your device, and the keys roam among Apple devices or among your Google devices or among your Windows devices, but not between them. So I don't really know if the user story of that is very great, because I imagine people will be like, oh, I signed up with my Android phone and I logged in with WebAuthn, but I can't log in my Windows PC because there's no sync there. So you could make the account support, basically multiple, the Google WebAuthn key and the Windows WebAuthn key and the iOS WebAuthn key on my side. And I probably will do that if I implement it. But it'd be kind of cool if you could use a password manager, 1Password, whatever, and let it kind of have it across it all. So it's okay. So anyways, that's something I want to do in the future. It's kind of a cool project. I prototyped it once, but it wasn't quite there, so I haven't done it. So yeah, so on the client side, the way it works is that if I go back here, you can see that it's prussia.october.com, because if I go to my dashboard, the printer's name is Prussia. This dashboard's kind of cool because it shows you some quick statuses. Like I said, gadget. This is how you get to the live link to create the little link I shared. quick view gets you to that. So anyways, that's a tangent. But so the name becomes Prusa.october.com, and this is unique to my account. So these printer names are unique. They have to be unique to my own account. They have to be, yeah, unique on the account. And the combination of the subdomain plus my user authentication in Octo Everywhere is what then gives me access to this printer. The first time, so at that point in time, like someone said, it is just a basic reverse HTTP proxy. And so I try to not mess with anything as much as possible. So the only thing I remove on the web call is like the Octo Everywhere cookies, so they don't get forwarded to Octoprint. Just very basic stuff like that. Everything else I try to keep exactly the same, so that any plugin you install doing any random crazy thing, you know, setting, I don't know, headers or something, doing weird things, will just work, and there's no problem with it. And so, yeah, so when you first get there, you have to log in, because Octoprint, you know, you don't have a cookie for Octoprint because your browser doesn't have a cookie for it. So you have to log into your account, and I'm like logged in here, and then you get the portal and all that jazz. So basically, your browser reaches out to my server through HTTPS, all the standard HTTPS stuff, creates a secure connection to it, and then the server, since it has a connection to the printer, takes your request, bundles it up, sends it on the WebSocket. The WebSocket spits it out to Octoprint locally, grabs the response back, sends it up to server, spits back out to your browser. I had to support HTTP calls, WebSockets, so like real-time multiplex or duplex streaming WebSockets. Because most of all the Octoprint UI is driven on WebSockets. Let's see, the WebSocket. It's kind of how it does like all of its like, actually, I think it does API calls, and also does this like general kind of event-based updating through WebSockets. So anyways, it's actually pretty chatty. But and then the webcam feed is MJPEG stream, which is actually kind of terrible, but it's not like a 264 video stream. So basically it's not temporally encoded, meaning that each frame is independently the encoding is basically, it's compressing the frame itself, but not compressing between frames. So, you know, normal video encoding, the deltas between frames, the duplication isn't sent, because the codec can just say, hey, just take everything on that old frame and then add this on top. But with JMPEG, it's just sending JPEGs literally that are back to back to back. So the JPEGs have no relation to each other temporally through time. So it's pretty inefficient. But I also had to support that stream. I think they're actually working on implementing WebRTC in Octoprint, which would be really cool. It's supposed to come out in like December, so if they get it out in time. So WebRTC uses 264, 265 VPN9, like modern video codecs, so it should be way better in terms of bandwidth and quality and stuff. Yeah, so that's that. Oh, so the October Cloud. Yeah, it's motion JPEG basically. It's like super old. Basically, I think the reason why is because it's really simple. There's a server running MJPEG streamer. It's like this common thing. It's like a Linux thing a lot of people use. It doesn't require much compute. It can run at like they run at pretty low resolutions and pretty low frame rates. Where like H.264, with like Pi 3s and Pi 4s, they have hardware encoders on them for video, and I think most devices now have hardware encoders for at least 264. But without a hardware decoder on a Pi, it would not nearly be able to do it in real time. So anyways, it's just basically way more simple. And so that's, I think, why it was used initially. A lot of IoT projects, like a lot of like IP-based webcams and stuff, use motion JPEGs. Like almost every IP webcam I've seen. People, Octoprint supports using an IP-based webcam. You can go to the Octoprint UI and then set up an IP-based webcam. And so like, you know, your browser then is talking to Octoprint, but for the webcam, it's talking to another local device on your LAN. Which I can actually talk about in a minute, because that's kind of interesting how I solved that. But the Octo Everywhere Cloud, so my core priorities for it were basically low latency and reliability. I was telling Peter earlier that I'm the only one that works on Octo Everywhere, and I have a life. So having Octo Everywhere be super reliable, super robust is great. I don't want to go wake up in the middle of the night to fix it. So I try to use like hosted services whenever I can, as long as they're secure or whatever. I use like Influx, and I use Influx Cloud, which is super great, super cheap, highly recommend. But so I don't have to host my own Influx, manage its security, it's off, all that jazz. So anyways, I have 8 server clusters around the world. So the point is to have a server cluster as close to people as possible, since it has to make, from you to the server, to the printer, to the server, to you. So that's, your RTT is the round trip time. So it's RTT times 2, because it's 1, 2, 3, 4. it's 4 single ways, 2 double ways. So anyways, 8 locations around the world for the compute. And then for Gadget, the AI system I have 4 clusters around the world that handle all the compute for that. And Gadget, like I said, I'll talk about more in the .NET one later. And so printers basically have a latency detection logic. So they have a way of, in the background, pinging all the servers and finding which one has the lowest latency for it to connect to. And then going forward, it will connect to that server. It does that like every 32 hours, something like that. So like it updates that every now and then. It basically averages out the lowest connection, the lowest latency, and then we'll use that one. The browsers use Azure Traffic Manager, which is just a DNS-based way of routing traffic. And Azure Traffic Manager is supposed to look at your IP address and be like, oh, your IP is in Seattle and there's a presence in Oregon, so I'm going to route you there. Like basically trying to estimate that. It's kind of wrong sometimes, because I think IP-based geo lookup is a little flaky, but it's like 95% of the time correct. So you get to the lowest cluster doing that. So the good thing is that if your printer is connected to the same cluster you're connected to, then you just, proxy the cluster, everything's good. The problem is if you're traveling and your printer is connected in Seattle, like mine is, so San Francisco is the closest data center I have. So mine connects to San Francisco, and I went on a trip to Italy last month, and I was able to access my printer from there. And but my browser will get redirected to probably Frankfurt, which I think is the closest data center I have to Italy. So the question now is, now you have these 2 things connected, and how do they talk to each other? So the servers kind of form this like mesh. They're aware of each other, and they can communicate among each other to like figure out how to route this correctly. I was considering proxying traffic between the actual servers on the back end, but I think it's actually more latency because it's just more hops. So what happens is that if you go to a server, like if I go to Frankfurt, and so octariver.com, just the naked domain name, will take you to Frankfurt. And then my printer is connected in Seattle to San Francisco. It'll redirect you to prusa.sfo.october.com. And that .sfo forces you to go to the cluster in SFO. And then now basically your printer is connected there and your browser is forced to connect there. So now you're paired again. But for some apps and some setups, they won't follow the redirect, basically the HTTP redirect, because they're assuming it's just october.com. And like every API call they'd make would have to like redirect, and some don't follow them at all. So in that way, the servers are able to kind of broadcast a message out among the mesh and say, hey, if you find this printer connected to you, tell them to come connect to me. And so the plugin has a way of receiving a message from the printer it's actually connected to, and the printer it's connected to in San Francisco will say, hey, go connect over to Frankfurt, because I need you to go talk to someone over there. And the plugin will do a simultaneous connection between the two and stay connected to San Francisco, but also connect Frankfurt. And then since you're paired, then you can do all the proxying you need to do. And then eventually that secondary connection, after it's not used for like an hour or something like that, will like disconnect and it'll go back to its primary connection. So that's kind of how that works in terms of routing and the mesh network that kind of mesh the server clusters make. And then the other great thing about that is reliability. So I run on DigitalOcean, and they're not as robust as Azure is. When I had Azure VMs, they went down a lot less often, or like they were always internet connectable a lot less often. It wasn't necessarily that the VM goes down, it's just sometimes the connectivity gets a little wonky. DigitalOcean is great, and I absolutely love them. But they're not quite as reliable as Azure, but they're also like way cheaper. So that's probably why. But it doesn't matter in my case, because I have these 8 server locations, and the server locations can handle basically about double their load in terms of capacity. And so if a server goes down, like the New York cluster, Azure Traffic Manager is pinging the servers every now and then, and will realize when one goes down. And the plugins will, the WebSockets do a ping pong. And so if the TCP connection doesn't close, it doesn't get the FIN TCP packet, then eventually the WebSocket will realize that there's no one on their side anymore and time out. And basically, Azure Traffic Manager will start directing traffic away from New York, and then the plugins will then go somewhere else. And basically, I can take out New York, and within about 10 to 30 seconds, everyone will reconnect somewhere else. The most like ideal location beyond New York, which is I think Toronto right now. I have a cluster there, and then everything's fine, and users never even notice. It happens about, I'd say about once every 2 weeks or something. One of the clusters will go offline for like 30 minutes just because they lose connectivity for some weird problem. I have like New Relic set up to do all monitoring on them, so I know when they go down, or like when they're not internet connectable at least. Anyways, so yeah, so it's kind of cool. It's really robust. I've never had a problem thus far where like a significant enough of the cluster has gone down that it became a problem. So that's really nice. And then it heals when it comes back online. It'll heal. Azure Traffic Manager automatically start sending traffic there again. The plugins reconnect to their primary server every like 23 hours, something like that. And so if the Octoprint isn't restarted for like if it's running for a really long time, eventually the plugin will disconnect and reconnect to the newest one where it should be. So this is just kind of stuff I was writing about security if people are interested, but I do a lot of stuff. I've thought about a lot, like all the resources I use Cosmos DB for all like the super critical stuff because it's super reliable, built by a big company. They have like really robust security, two-factor push off and stuff. Like to access the portal, I have like, it's almost kind of like JIT access to it, but that's all set up. It's only it's whitelisted. So basically it's behind a secure, obviously connection string, but it's also whitelisted IPs. The credentials are rotated. I run latest version of Ubuntu, update it daily, like all the packages daily. The SSL certs are generated per box on the cluster by a little thing I wrote using Let's Encrypt, like I said. The SSH is really locked down to the boxes. You basically can't really get on them because I don't really need to. And the service is written in .NET 7. I just upgraded like the day it came out because I wanted something to do and it looked fun. The Octoprint relay logic is all .NET 7. And then all the APIs are also using all the the API handlers in .NET Core, whatever you call those. I don't know what that system's called. I guess ASP.NET, I think is the right terminology. Yeah, and Nginx runs in front of it to do SSL termination and so like basic rate limiting, just so everyone gets to .NET. And then yeah, so I don't know why I listed things I use to run it. This actually isn't even all of them, but it's all this stuff is required to run something like this. It's kind of incredible. I've never really ran anything like this before. I've also never I run the service, the support, the socials, the business. I have to have like some business around it. Like I have to report taxes and stuff to the state of Washington where I live. So doing all that's really new to me. And so I use Azure mostly for databases and traffic manager and service bus. And then I use DigitalOcean for everything else, compute. I have a managed MongoDB instance I use in DigitalOcean for like non-critical, just data that's kind of transient. Azure DevOps to deploy things. GitHub is where I host the code on private and public repos. Cloudflare for all the website. It's basically all super CDN, except for the API calls, obviously. Not just the website, not the Octoprint portal stuff isn't CDN at all, because people can have different versions of like JavaScript files and whatever, depending on what version of Octoprint they're running. So Grafana, Influx for all my telemetry. I use Grafana Cloud, which is great. I use the free version of it because I only have one dashboard. Influx, I have a million graphs on it, but I only have one dashboard. Influx is great. I feel like a ton of data out there, and it only costs me like $2 a month, which I think is just phenomenal. Super cool. FreshDesk is great. I use it for support. I use the free version. Don't have to pay for it. It's like an email-based support system. Really nice way to organize it all. New Relic for all the monitoring. Logly for some log stuff. ChargeBee is what I use for my subscription support. It's basically a subscription abstraction on top of Stripe and PayPal and other payment gateways. It's really nice. Stripe, PayPal, SendGrid for email, which is really expensive, unfortunately. And then OnePostal is like a virtual mailbox I use and stuff like that. So yeah, anyways, that's all the content I have. And I have to run at 12, which is in 5 minutes. But I'm happy to answer any questions. On now it's only 4 minutes. Any questions or anything? People have anything?
That was really good. Thank you very much.
Yeah,
Yeah, that's really interesting.
I hope that was engaging.
Yeah, definitely.
I always watch tech talks when I went to Purdue University, and whenever people came in and just gave like a pitch about the company from like HR was boring. I always liked it when the engineer came in and talked about something interesting. So,
Yeah.
so I try to have some technical, interesting stuff in there.
Yeah, I agree. Yeah, and
Yeah.
obviously, don't forget, sometime in the new year, Quinn's going to come back to .NET Knots and talk about the .NET elements of all of this as well. So you'll get a fully rounded view of this if you want to come along to that one in the new year. So
Yeah. I'll probably focus on like the hosting side more, like I was talking about. And
that's
I was
fine.
talking about like the AI system. It's actually pretty cool. It processes 3 million images a day, which is pretty
Wow.
incredible. I
Yeah.
didn't know it could really do that. But and so basically it's like it's taking images of this print and then looking for failure detections. And if it finds a problem, it'll send a notification or pause the print itself to prevent waste or whatever. So I just launched that like a week ago, and a lot of people seem to really be enjoying it. Seems to be working well. So I'm really happy with that. Oh, and I'll mention, so if you want to, you don't even have to use Octo Everywhere, but I have a launch. So if you go to octoeverywhere.com/launch, or click this banner, you can see some stuff. I like to do some giveaways and stuff for users. So you can enable Gadget. And then I'm doing a thing where you can get 30 days of perks. You have to put in payment information because that's the only way I can do it, unfortunately, for 30 days. But you can cancel immediately if you want. So you can just do it, get 30 days, and just cancel it. And then won't renew, and you still get your 30 days. And then I'm also doing a giveaway where I'm giving away a Prusa printer, which is a super nice printer, and free supporter perks for life, which is kind of fun. Just for something fun to do. All you have to do is like follow the Twitter, retweet this thing, whatever. And then there's also a Reddit one I did, which I'm gonna end in like a little bit. But if you want to, all you have to do, I'll post it again in chat. All you have to do is put a comment there, and then I'm just gonna pick one person to get another 3D printer. So if you want a 3D printer, it's a great way to try. Yeah. Are there any questions beyond that, or did I just talk so much that everyone's like, oh?
Chris has put something in the
yeah, sounds useful. Yeah. So the AI stuff isn't necessarily new to 3D printing. There's some other services that do it, and other really great services as well. There's one called Obaco and some more enterprise focused ones. I just thought it'd be a really killer feature for Octo Everywhere, and I wanted to, implement it for my community. The big thing I was able to do is that Gadget is free and it's unlimited. So the other ones have basically time limits. You can only do like so many hours per month of watching, which if you print even a decent amount, you kind of run out of. But luckily, I was able to implement it in such a way that I can pay for the compute power of it while still offering it for free, and in an unlimited way for the whole community. So I was really excited by that. And if you go to october.com/gadget, you can read some stuff. There's like a little intro. This is what it looks like once you set it up. You could kind of set how confident it'll be, turn on and off the print, the pause, and you can enable, disable all of it. So yeah, I think it's the community really seems like it. It is a big saver, especially if you have like print running overnight and it fails like right when you go to bed. You don't wake up to a massive thing of spaghetti of all this wasted filament that you have to go buy more filament. So yeah,
I love that idea. Great.
Yeah, it's cool.
Yeah. Well, I better let you go and do your day job, Quinn. Really appreciate you coming on.
Yeah, well, thanks for having me. It was a lot of fun. Really enjoyed it, and I hope you guys did. And watch out for the one in probably end of January, somewhere around there.
Yeah. Sounds good. All right.
Cool.
Thank you very much. We'll call it a night at this point, everyone. So we'll catch you all again next year.
See you in the new year.
See you later.